Let's go. All right. So then, watch this now. So we actually have two transversal here. This is one, and this is another one. You understand? Because they cut across the parallel lines. All right. The first question says, determine the value of Q and R. Q and R. Now, right now, as you could see here, the value of R here is 54. Yes, so R is 54 degrees. Vertically opposite angles are equal. So this here is 54. All right. Now, you want to look at Q. Well, there are a number of things that you can do to find the value of Q, right? You can work out a number of things. One of the things that you could work out, though, is the fact that this idea, if you, I think called co-interior. If this line is parallel to this, cut by another line, right? These two angles on the inside, which are on the same side of the transversal, they add to give 180 degrees. So in other words then, Q and R will add to give 180 degrees co-interior angles. So Q, you can find Q by saying 180 minus 54. But then again, no, to get the Q, co-interior angles add up to give 180 degrees. So Q is 126 degrees. This is 126. That's why I said you're going to have to do something to study on it. Okay. That form a little Z thing there. So they are saying the angle form here is the same thing as the angle there. And give a geometrical reason why P is 71, and I just told you it is 71. You see?
Yes, sir.
And they are saying give the reason why it is 71. Well, yeah. So what they are saying there is this alternate angles are equal. So those two angles are alternate, and they call them Z angles. Just a little nickname because it's shaped like a little Z. So Z angles are equal. Triangle X prime, Y prime, Z prime is the image of XYZ. See that? Of XYZ, which is not there.
No.
All right. So an enlargement of that, of scale factor that, and center that. So the center for the enlargement was 5,1 right here. So that was the center of the enlargement. And they are suggesting that there's another triangle that was double up and it become this. That's what they're saying. All right, so look, triangle X prime, Y prime is the image of another triangle that is not here. All right. All right. So now they said draw XYZ, the object of this on the grid. All right. Now, there are many ways you could go about this. I'm going to show you some. The moment they're dealing with enlargement, you can get some lines out from where they said the center is and draw it through the edges or the vertices of, watch, and let me put the lines in green. So you notice from the center, I'm drawing it through Y prime. I'm going to explain. I'm using it kind of to teach us so. Same time. Hold on. The most I give me a little problem. And then the next one is that I want to draw this from the center through X prime. You see that?
Yes, sir.
And the last one, I'm going to draw it from the center. Hold on, the most more. If I realize I did it, I wouldn't go for the next line. See there? All right. So what I'm saying is the triangle that you're looking for will shape just like this blue, will shape just like this. And it's gonna be between here, halfway between here, where the center is, and the other one up here. Halfway. So you can check how far you travel to go there and go half of it. For example, look at this. How far did you travel from here to go down to Z? Let's focus on Z. 1, 2, 3, 4, 5, 6, 7, 8, and then 2 up. So you do 8 and 2 up. That means to find the corresponding point feet. Since the scale factor was 2, it's like you're going to come half. So you're going to come 4 and 1 up. For example, 1, 2, 3, 4, and 1 up. So the Z is actually right here. All right. So the Z was at right here. Halfway. So you see on the lines that you have, halfway to the journey. All right, let me tell you another thing. Look at this line to the point from the center, halfway. Can you see that where I stopped just now was half of it?
Yes, sir.
So that's where Z was. Z was right here. And if you look at the other one, this would have been the next half. And the other one, this would have been the next half. You're able to see half of it.
Yes, sir.
And then now so this would have been the X and this would have been the Y. Recreate it now. See there now? There it is. Hold on. There. See there? So I'm suggesting that because they said it's an enlargement and they give it the center, they told us that the center was 5-1. I'm saying to you, from where the center is, you will draw lines to the image, to the vertices of the image. And then now, because the scale factor was 2, the concept is that you are going to go halfway, because scale factor of 2 would have meant that the image would have been 2 times everything for the object, because the object would have been there and the scale factor of 2 double everything. So it will even double the distance from the center. That's why I did it like that. So if you walk 4 to the left and 1 up for the object, you're gonna have to go walk 8 and 2 up because everything double, because they said the scale factor is 2. And if you look at the sides, where this would have 4, this will have 2. And wherever you see 2, the next one will be 1. So you can see that it was really double when you think about it.
Yes, sir.
All right, so that's one piece out the way. The object. So we drew the object just now. Next question says triangle. Watch this. X prime, Y prime, Z prime is mapped onto this. So they are saying that this one was mapped onto that one. All right, that's all. So they are asking you by a reflection in the line P, state the equation of the line P. So they already told you that it's a reflection in the line P. What a reflection does, it's gonna come halfway between image and object. Let me color the image and the object. See them here? This is one, and they're talking about this. So you're thinking about them. And they told you that but when you look at it and you think, you kind of understand, say, if it's a reflection, the mirror line is going to be halfway between them. So you could have looked. You can see that this is like the mirror right here. This red line I'm drawing here is the middle. Because if you should look at Y, 1, 2, 3 to the right, and then 1, 2, 3 to the left. So you're seeing that splitting in 2 of the idea. So this line is called X equal 2 because it passes through 2 on the x-axis right there. So that's the line P that they're referring to. P is x equal to 2. That would have been the so-called mirror line, which is equal in distance from object to image. So it's x equal to 2, which would have been the mirror line. Yeah. Three functions f, g, and h are defined as f of x is equal to 2x minus 1, g of x is equal to 3x plus 2, h of x is, that's 5 raised to the x. All right, that's 5 raised to the x. Looks funny. It's, this is saying h of x is 5 raised to the x. All right, so the questions are as follows. Find the value of f of half. So if you're going to find f of a half, you want to grab that f function, 2x minus 1. And if I'm going to find f of a half, I'm going to be putting half in the f function where x is. And that's the only place you do substitution. You put it where the x is. There you go. Then you minus 1. So looking at it, this is 2 over 1. You could see this cancel, get 1. 1 minus 1. This gives us 0. So f of a half is a 0. H of 0. H of x is needed to work out h of 0. So h of x is 5 raised to the x. So if I want h of 0, then it's going to be 5 raised to the power of 0. And in indices, anything raised to the power of 0 is 1. So this question says you want to do g square of -3. But what g square is you have to understand that g square really means g in g. That is how you get g square in a function. It's g function in g. You could put g in g, and then when you're done, you put 3 where x, -3 where x is. The g function is, what is the g function? 3x plus 2. G square means that you're going to put the g function in the g function. So, and you know that when you put in a function, it only can go where the x is. So I'm just writing it for you to see. Can you see that?
Yes,
so
sir.
Put in the g function in itself. And then now you're going to have to unravel what it is. So I'm going to use a color scheme to kind of help lessen the confusion. Remember that this is 3x plus 2. Watch this. Change back the color now. Plus 2. See there? So I just put the g function in its own self. That is what they call g square. Then now you're going to have to execute, because 3 is given 9x. Then you get plus 6 plus 2. So basically, I'm looking at 9x plus 8. No, that is the g square of x, is that. So now if I want to do the -3 now, I'm going to have to put -3 right there. See that? So you find something for the g square, then you work out that. So this is -27 plus 8, and this is like -19. Inverse of g. All right, so this is kind of looking palish. They're asking for this. The inverse of g of x. So we're talking about 3x plus 2. All right. Originally speaking, g of x is equal to 3x plus 2. In order to find the inverse, I normally suggest that you rewrite the function using y, because g of x is a form of y. So you could say y is equal to 3x plus 2. So it's like we're saying, let this happen. So let y equal to 3x plus 2. But the idea behind an inverse is really built on the fact that an x and a y switch place. Are you okay with that?
Yes, sir.
So then you're going to switch literally where x is you put y, where y is you put x. So x is equal to 3y plus 2. Transpose for the new y. So in isolating the y, you're seeing that we'll subtract 2, balance by subtracting 2. So x minus 2 is now equal to 3y. Then you divide by 3, divide by 3. So x minus 2 all over 3 is equal to y. You could now finalize by saying the inverse of g of x is x minus 2 all over 3. Good?
Yes, sir. Oh, sir, can I go up a little bit for a second, please? I didn't write the last part. Thank you.
It says hence or otherwise, determining the value of g of x equal 4. The inverse of g of x equal 4. All right, so what we have an expression for the inverse of g of x. See it here? And they are saying hence or otherwise determine the value of x when this is equal to 4. Well, we can say, because we know that g of x is the inverse of g of x is this. And you want me to tell the value of x when it is equal to 4. Okay, therefore, I will just let this equal to 4. Oh, that's so. Like 14. They're saying to us, find the value of x when this is equal to 4. So let it equal to 4, then solve for x. Ordinary, multiply everything by 3 to get rid of the denominator here. X minus 2 is equal to 12. Then you add 2 to both sides, and x is equal to 14. So right there you see x is equal to 14. And you're done.